Right now, as you hear these words, a version of you finishing this video already exists. So does a version who clicked away 10 seconds ago. Not as metaphor, as geometry. Einstein's equations suggest your past, present, and future are equally real, sitting side by side like pages in a book. You're not moving through time. You're moving through space. And that changes everything about choice. Here's what I mean. By the end of this video, you'll understand why trying to manifest or force your future doesn't work, and what actually does. You'll see choice as path stabilization, not reality manipulation. And you'll walk away with a practice that turns physics into daily action. No woo. No delusion. Just clarity. But here's the paradox. If all moments exist equally, where does choice actually live? Can you change a future that already exists? Hold that question. The answer isn't what you expect, and it solves the entire free will debate. We'll close that loop in the final section. But first, there's a reason physicists had to solve the arrow of time problem before any of this makes sense. Without understanding why time feels one way, the whole all moments exist claim falls apart. The answer involves coffee, cracked eggs, and something called entropy, and it's simpler than you think. If time didn't seem to move one way, cause and effect would blur. Memory would lose its anchor. You'd wake up unsure whether your breakfast came before your alarm or after your commute. The thing is, our sense of direction in time doesn't come from clocks alone. It comes from entropy, the tendency for energy to spread and arrangements to move from neat to messy. Okay, so basically entropy is a statistical trend. Hot coffee cools. Ice melts. Eggs crack but don't uncrack. Why? Because there are far more ways to be messy than to be ordered. Disorder wins by sheer numbers. Think of colored marbles in a box. There's one way to keep all reds on the left and blues on the right, and astronomically many ways to mix them. Shake the box and mixing wins by sheer numbers. Here's the weird part. The fundamental equations for particles don't prefer yesterday over tomorrow. They work just fine forwards or backwards. Yet the macroscopic world clearly favors one direction. What this actually means, the arrow isn't a cosmic law. It's a statistical consequence. Our universe started exceptionally ordered. From that starting point, disorder becomes the most likely path forward. The arrow emerges from the math, not from fate. Coffee meets cooler air, heat disperses, order decays into options. In other words, time's arrow isn't a metaphysical fate. It's a bookkeeping reality about where energy goes and how likely patterns are. That's why it's brutally hard to get an egg back into its shell. You'd need near infinite information and precision to reverse every microscopic motion. Possible in principle. The equations don't forbid it. Practically? The odds are so tiny they're effectively zero. Let's ground this. Morning. You pour a fresh coffee. Steam drifts. Within minutes, the mug cools. You reheat it in the microwave. Did you beat entropy? Not really. You pushed energy into the coffee by pulling more energy from the grid, which itself sheds waste heat to the environment. Locally, the coffee's entropy dropped. Globally, the total entropy rose. That's the playbook for refrigerators, bodies, cities, and stars. Life creates little pockets of order by exporting disorder somewhere else. The arrow holds. Why does this matter for your felt experience of time? Because we often confuse the smoothness of experience with a universal flow. Your brain stitches moments into a coherent now. Entropy supplies the preferred direction that makes those stitches make sense. Memories are records of lower entropy arrangements, not previews of higher entropy ones. You remember the mug full and hot, not the dispersed heat that left the room, because records themselves are low entropy structures embedded in matter, synapses, photos, notes, carbon layers. Quick question. Have you ever tried to remember something that hasn't happened yet? Sounds ridiculous, right? But if you've had déjà vu, premonitions, or dreams that seem to preview the future, drop A in the comments. We'll circle back to why that might not be as mystical as it seems. One quick clarification: entropy isn't a moral law. Messy doesn't mean bad, ordered doesn't mean good. Entropy counts arrangements. A jazz improvisation is thermodynamically ordinary, even if it's meaningful. Your tidy desk doesn't suspend the second law. Keep the categories clean. Physics tracks energy distribution, meaning lives in patterns we care about. The arrow doesn't forbid reversals, it just makes them vanishingly rare. Strike a match and you open countless futures. Reversing it. You'd need to aim for one microstate among trillions. Pause for a second. I know this feels abstract. Entropy, microstates, arrangements, stay with me. Because here's where it clicks. You already know this. You've lived it. Every time you've tried to unscramble an egg, reassemble a shattered mug, or unsay harsh words, you felt the arrow. Not as philosophy, as friction. The universe saying, that direction is easy, this direction is nearly impossible. Now let's see what happens when we tilt the road that arrow runs on. Why this matters for you? When you understand that the arrow isn't fate, just statistics, you stop fighting reality and start working with it. You export disorder strategically. You build islands of order by design, not by grinding. So entropy gives time its arrow, the statistical push from ordered to disordered, from few arrangements to many. It's why your coffee cools, why eggs don't uncrack, why you remember breakfast but not tomorrow's lunch. The arrow is quiet but relentless. But here's what entropy doesn't tell you. Whose arrow? Your arrow? Mine. That's satellites. Turns out the road the arrow runs on can tilt, stretch, and warp depending on how you're moving and where you stand. The arrow still points forward, but forward itself isn't universal. That's relativity. And it turns time from a river into something stranger, a landscape you slice. Now, entropy explains why time feels one way. But relativity reveals something stranger about what now actually means. And this is where your personal experience of déjà vu, premonition, or knowing what's about to happen gets interesting. More on that in a moment. First, the geometry. Okay, so basically, relativity swaps the river of time for a loaf. Think of space-time as a whole loaf of bread. And now isn't the whole loaf, it's a slice. And here's the key. You, me, and that satellite overhead each cut our slice at different angles. Motion tilts your knife. Gravity tilts it too. Try this. Pause for 5 seconds and picture the loaf. Your entire life, birth to death, as a solid object. Past you, present you, future you all exist in different slices of the same structure. Weird? Beautiful? Terrifying? Let me know in the comments what emotion hit you first. Imagine you and a friend each hold one end of a long rope stretched across a field. You both mark now on your sections at the same instant. But if your friend starts running toward you, her now mark slides along the rope, what she calls simultaneous shifts. Spread this across light years instead of meters, and those shifts become massive. An event that's now for you might be yesterday or tomorrow for someone moving past you at near light speed. If you think about it this way, simultaneity stops being sacred. Two events that I say are happening at the same time can land on different slices for someone zipping past me. Spread the distance far enough, and tiny tilts in the slice become huge disagreements about what counts as now. That's not philosophy. It's how the geometry of space-time works. Motion changes the angle of your slice. Here's what most people miss. Time dilation isn't speculation, it's measured. GPS satellites orbit fast and sit in weaker gravity. Their clocks tick differently than yours. Engineers correct for this constantly, or navigation would fail within hours. That's the loaf in action. Different slices, different slices. Now, extreme gravity does something even stranger to the loaf, something that sounds impossible until you see the math. Near a black hole, time doesn't just slow. It nearly stops from one perspective while flowing normally from another. Two observers, same event, radically different experiences of when it happens. Hold that paradox. We'll need it when we talk about quantum measurement. The counterintuitive part is black holes. Near a horizon, the slice tilting becomes extreme. From far away, anything falling in appears to slow, redshift, and almost freeze as it approaches the boundary. Time for the infalling object doesn't stop in its own experience. It crosses the horizon and continues. But to a distant observer, the signals stretch out, dim, and never show a crossing. Same event, two very different slices. The observer effect here isn't about consciousness, it's about reference frames. Wild, right? You're probably thinking, okay, but what does a black hole have to do with my life? Fair question. Here's the bridge. If motion and gravity can stretch time until it nearly freezes, if your now is just one angle through a loaf, then the felt experience of flow. That's you, not the universe. The conveyor belt you think is carrying you forward doesn't exist. You're the knife slicing through the loaf. And that subtle shift from being carried to being the slicer is about to matter when we talk about choice. Everything clicked when I realized the loaf view quietly suggests a block universe. The entire loaf exists, the pasta slices behind you, the future as slices ahead. We feel flow because we experience slices in sequence, not because the loaf is sliding past us. In other words, flow is perspective. The geometry itself doesn't require a moving present. That sounds unsettling, but notice how consistent it is with what we already measured. Moving faster changes your angle. Standing deeper in gravity changes your slice thickness. Here's a micro story to make it tactile. You're on a red-eye flight. Your friend is at home. You both set identical watches at the gate. You race east overnight, she sleeps. When you land, tiny nanoseconds disagree. You didn't feel it. She didn't feel it. Yet the universe kept perfect books. Your path through space-time gave you a slightly different slice count than hers. Scale that logic up to satellites, and navigation works. Scale it up to galaxies, and now spreads into a fan of angled cuts. In other words, the loaf view gives three payoffs. First, now is local, not universal. Second, clocks aren't ultimate, they're path-dependent. Third, extreme gravity can stretch slices so much that time looks nearly frozen from far away while feeling normal up close. None of this contradicts entropy's arrow. It just shows that the road the arrow travels can tilt, stretch, and warp. What you gain from this, knowing that now is relative, frees you from the tyranny of universal time. Your pace doesn't have to match anyone else's. Your path through the loaf is yours. That's liberation, not limitation. The loaf view gives us this. All slices exist, spread across the geometry like pages in a book. Past, present, future, locations, not states of being. But wait. If all those slices exist, Why do you only experience one? Why does this moment feel singular, definite, real, while yesterday feels like a ghost and tomorrow like a fog? If the loaf contains every moment equally, what picks out this slice as the one you're aware of? The answer involves something called decoherence. And no, it's not consciousness magically collapsing reality. It's something more interesting. Something that happens trillions of times per second in your brain, your coffee mug, and the air around you. Let me show you. That question takes us from Einstein's geometry to quantum mechanics. Because while relativity tells us how moments coexist, quantum measurement explains why only one feels real at a time. It's where possibilities live together until something, an interaction, a record, a choice, carves out a definite path. Okay, so basically, a quantum state is a catalogue of possibilities and their weights. Before a measurement, an electron isn't here or there, we just don't know. It genuinely exists in a superposition, a blend of here and there. This isn't ignorance. It's ontic uncertainty. Reality itself carries multiple options. They all exist until something forces a choice. Only when the system interacts with something that can record an outcome, a detector, an atom, your retina, does one result become the stable fact we remember. Think of it like this. Imagine you're in a dark room. In the classical world, a coin on the table is either heads or tails. You just can't see which. But in the quantum world, the coin is both until you turn on the light. Not secretly one or the other, actually both, existing as a blend. The moment the light hits it, the blend collapses. One outcome becomes real. The other, equally possible a split second ago, vanishes like a dream you can't quite remember. Now here's where it gets spooky. Einstein's word, not mine. Create two of these quantum coins, entangle them and separate them by light years. Measure one and somehow the other knows instantly. No signal. No delay. Just connection. Mystics love this part. But before you jump to consciousness creates reality, let me show you what the physics actually says. Here's what most people miss. The observer effect in physics means the measuring interaction changes the system, not that a human mind has to stare at it. A cloud chamber, a photodiode, or a molecule in a gas can play observer by entangling with the quantum system and carrying away information. Once that happens, the delicate quantum coherence that made the superposition possible leaks into the environment. We call that decoherence. It's not mystical collapse. It's a practical process. The environment tags the system with information. That kills the quantum interference. Outcomes start behaving classically. In other words, measurement has two jobs. First, it correlates the system with a device so that this outcome matches this pointer reading. Second, decoherence makes those correlations robust so they don't immediately unmix. That's why we don't see tables in ghostly overlays, even though their atoms are quantum. Everyday objects are constantly measured by air, light, and thermal noise. The quantum phases that would allow visible superpositions are shredded almost instantly. The counterintuitive part: quantum correlations are stronger than any classical explanation allows. Measure two entangled particles light years apart, and their outcomes stay mysteriously coordinated, yet no signal travels between them. It's connection without communication. Physics has tested this thousands of times. The correlations are real, non-local, and utterly strange. Here's what I love about this. Quantum mechanics sounds like magic. Particles in two places, spooky connections across space, measurements creating reality. But strip away the mystique and you get something more interesting. The universe is fundamentally relational. Nothing has fixed properties until it interacts. No particle is here until something asks. No clock ticks at an absolute rate until you compare it to another. Think of it like a conversation. The words you speak don't have meaning floating alone in your head. They mean something because they land in someone else's ear, get interpreted, create a response. Quantum mechanics says reality works the same way. Interactions write the story. And that brings us back to time.